bit. So bit is nothing but a low level language. Low level language is nothing but a machine understandable format. Okay, 0 and 1, nothing but a bit is nothing but a 0 or a 1. 0 or 1 is nothing but a bit. 0 and 1 is a binary format. Okay, you have a machine, right? So let's say you have your own PC, right? So this PC will understands only 0 1 format. Okay, like we have sequence 1 0 1 0 or 0 0, like this sequence will understand only by this PC. So this we won't understand, right? So this is a readable format for PC. So everything, so we have written like this now, like suppose if we write R3 R34, so this will convert into this format by a Java program. Okay, whatever we are using Java software, right? So this is responsible to convert to this format. Okay, I think I have cleared the what it mean by bit. So this is a simple introduction to the bit. Now bitwise, suppose let's take like this, people are standing. So some people are standing, example. So one after another, what do we will call one after another, right? Like persons wise, this flow is nothing but a persons wise, either in this flow or in this flow, one after another, right? One after another is nothing but a persons wise. Okay, same way if you have sequence of bits like this, example. So I will explain bitwise. So one after another, this flow, okay, in this direction is nothing but a bitwise manner. Now performing operation on bitwise, like one after another. Okay, on the bitwise, bitwise means on each bit if you want to perform operations, then we need a operators. So that is known as a bitwise operators, right? Okay, this is all about the introduction. How Java software or programming software will convert to the binary format. Okay, let's take every programming language. You take C, Java, Python, any software will convert using one like what we can say, one method, right? So this method involves 240, 241, 242, 243, 244, 245, so on. So in this format, from right to left, from right to left format. Okay, in this direction we need to write. So 240 is a 1, stage is a 2, 4, 8, 16, 32. Okay, now if you take a number, suppose if you take a number, let's say 4. Okay, if you take a number 4, then the software fit the number here 1 and remaining all zeros. So now say when we want a 4, see here it is a 4, remaining all zeros means it is a 4, right? Suppose if you want a 6 means what the binary, what the powers of 2 when we add, we will get 6 means here when we add 2 power 2 like 4, and when we add 2 power 1 2, then we will get a number 6, right? The remaining all it will keep zeros. Okay, suppose if you need a 5, okay, if you need a 5 means the compiler keeps 1 over here, and 4 plus 1 which is a 5, and remaining all zeros. Okay, once try out for your some another numbers, like if you take a 22 means it will keep 1 over here, like 16 plus 4 20, and next we need again 2, right? So here the software or compilers will keep 1, and remaining will be set to zeros. Okay, this is how the software will convert to a binary format. Since it is a binary sequence, right? So it is a binary format. Okay, types of bitwise operators. Okay, let us see one syntax also. So to perform operation we need a symbols, right? So for the bitwise and you need to use only one ampersand. For the logical and you need to use double ampersand. This is the difference between the logical and bitwise operators. Okay, here you need to use single ampersand, and here it is like or XOR, it is like a cap and not. Here there is a difference. For the logical you need to use exclamation mark, but here you need to use this symbol. Okay, so these are the symbols to perform the operations. Respective things over here. Binary format of this numbers is like 0 1 1 1 0 1 0 1. Okay, and same logical operation truth table. What the truth table we are discussed. For the AND, if you need to work means it is like a product, right? So it performs a product operation, right? It performs a plus operation. Okay, right now 1 into 1 it is like a 1, 1 into 0 it is a 0, 1 into 1 it is a 1, 0 into 0 0. Same 1 plus 1 which is the true, but here you need to write a 1 only. Okay, since it is a bitwise operation. 1 plus 0 it is a 1, 1 plus 1 2, but here you need to write a 1, similarly 0. Okay, since convert this into the value. Okay, convert this into the values, right? What is the value for this? What is the value for this? Okay, 1 0 1 it is like a 5. Okay, it is like a 5 value, and since 1 0 3 1 it is like a 7, right? Same this binary sequence only we have get. So now this is the new one for you, right? Like XOR operation. For XOR operation I will give you a truth table. For XOR operation the two different things you need to have. So either a 0 1 combination or 1 0 combination. When it will have means the output will be the 1, otherwise it will be the 0. Okay, like when it will be 0 means it is like when it is a 0 0, or when it is a 1 1 it is like a 0. When the two inputs are different it is like a 1. Okay, I think you got the idea. When the two inputs are different the output will be the 1. If it is a same it is a 0. Okay, see here I am writing input should be different, input different we need to have. Okay, here where the input is different, here it is the same, write the 0 over here, 0 over here. Okay, 1 and 0 it is a different, right? So you need to write a 1 here, 1 and 1, so same 0 0. 1 means, see, when I place 1 over here remaining all 0 means it is like output as 2. Okay, not operator. In the logical or in the bitwise, not operator is a unary operator. See, not operator is a unary operator. Unary operator means you need to only one input it will accept. Okay, so either you need to write with the A or B. I am going with the A. Okay, I am going with the A. So what the operation it will perform means, here I will going to give the description about the not operation. Where I am going to write means, let us declare all the things here. Not operation. Okay, so any number. So if you have number here n, okay, it is a n number, it will provide n plus 1 and it is a plus n, right? So if it is a plus means here you will get the minus, if it is a minus means here you will get the plus. Okay, so this is the operation it going to perform. 7 plus 1 which is 8. Change the symbol like minus 8. Now let us perform the bitwise AND operation like A and B. So what will be the output? So here we have, in the discussion we got the output as 5. Let us check the output. Let us verify over there. When I run the program, obviously we are going to get the answer as 5. Okay, let us change it to the OR. Let us change it into OR. It is a pipeline symbol. When I run it, here we are getting the 7. Okay, when I change it to the XOR, it is like a cap. We will found this in the we will get this symbol in the numeric 6. When I run this, it will get the output as 2 single input like not A. Not A means it will be, we are going to get like minus 8. Okay, like it will change the symbol and add plus 1. Suppose if it is a minus 8, then it will be like minus 8 plus 1, it is like a 7. So you have know the about integer scale, right? So after the 8 plus 1 which will be the 7, again change the sign like it is like a plus 7. Suppose when I change it to the minus 8, it will be answer like plus 7. Okay, this is how I explained. So it will be applied to the whole the thing, right? Like we have shifting operators and other bitwise operators. So shifting operators, so by the name directly we can say it is shifting something. What is going to shift? It will shift bits. Okay, it will shift bits. So we have a bits, right? Suppose if you take the 7, what is the bit value for this? Suppose int a equals to 7, then what is the value for this? It is like a 0 1 1 1. Okay, so here the possibility is like we can shift the bits either in left side or in the right side. So shifting operation can done in 2 types, like left shift, right shift. So right here left shift and right shift. Okay, now for the left shift operation we need operators. So the symbol is nothing but this one. For the left shift you need to use this symbol, for the right you need to use this symbol. 7 left shifted by 1 time means what? Okay, so let us take the positions. So this is the bit position, right? This is the 240, 241, 242, 243. Okay, so in the place this will comes to this place, this will come to this place, and this will to this place. So left shift by 1 means it will change the order. So when the 1 comes to here, it will like 1 1 and 1, here the 0. Okay, this will comes to this place. So here the space is left over now, so here keep the 0. So if we calculate the value for this, like it will like 8 plus like 8 4 2 1, right? So 8 plus 4 plus 2 like 12 plus 2 which is like a 14. So again if you perform 7 left shift by 2 times, it is like a 14 into 2, so nothing but a 28. Okay, now if you perform a right shift with respect to 1, then it is like we need to move in this direction. Like here we will get the 1 1 1 and 0 and 0. Okay, so this bit will got deleted, remember. So this bit will get deleted. Now only 2 ones will left. So if it is 2 ones means 2 power 1 which is like a 2, 2 plus 1 which is like a 3. Okay, 7 if we perform right shift by 2 times means nothing but 7 by 2 which is like a 3. Now 7 by 4 which is nothing but the 7 by 4. So remember, if we shift 1 time means to the left, it is like a into 2. If we shift 2 times means it is like a 4. Okay, if we perform 3 shifts means to the left it is like a 8. So if we perform right shift with the 1, it is like a divide by 2. If we perform 2 times means it is like a divide by 4. If we perform 3 times means it is like a divide by 8. Okay, remember, if you perform 2 shifts right means it will like a divide by 4. 7 divided by 4, nothing but the 1. Okay, now let us see the practical over here. Now this is like a 7, so remove this course also. Now here directly I am giving 7 left shift by 1 time. Now when I run the program, we need to get the answer as 14. Okay, now if you perform 2 times, it is like into 4, 7 into 4, which is like 28. Okay, now if you perform 3 times, it is like 7 into 8, right? Now see here, it is like 7 is 56. It is all over the left shift. Now similarly for right shift also, let us do once. If we perform 1 time right shift, then the answer will be 3. Okay, if we perform 2 times means the answer will be 2. Like 7 divided by 2, the quotient will be 1, right? Still it is running. Wait a minute. Okay, see here we got the 1. This is all about the right shift. So why this important means, I faced one question in the interview. So so the question is like perform. So this is the question I got personally in the interview. So that's why I am explaining to you.